everyone, it's Casey from the Montreal Student Network, and it's been a while since I've released a tutorial. I've been working on my university applications, so that's where I put most of my focus, but I am back to get into the real difficult part of organic chemistry, which is the mechanisms. That's where a lot of people have trouble, and I think there's, teachers don't put enough time into making sure students understand these mechanisms, because there's going to be a lot of them, and there's actually a very common trend in each one, which I want to show you guys. So we're going to walk through one of the first ones you're going to learn, which is turning an alcohol into an alkyl halide. And in this situation, we're going to be dealing with secondary or tertiary alkyl halides. And remember, that means when you have your functional group, which over here our alcohol, our functional group is the OH hydroxy group or hydroxyl group, it will be connected to a carbon, which is connected to three other carbons. That'll make it a tertiary. And we can see it's connected to three other carbons by this guy over here, and we're actually going to draw it out. So in case you guys have trouble visualizing it, I'll draw it out for you guys. So this is the overall reaction, and we're going to have our alcohol going to be forming with some hydrogen halide, which is going to be like an acid, a hydrogen with a halide, so HF, HCl, HBr, or HI. And they're just going to switch. The OH group is going to switch with the halide. In this case, it's chloride. So we're going to go and draw out the process. And a process is a mechanism. So first thing, we're going to start off by drawing our two reactants over here, the tertiary alcohol and the hydrogen halide. And we're going to go through it very, very slowly, because if you have trouble with your first mechanism, it could make learning the later ones a bit difficult. So for those of you guys who want to use this as an introduction to mechanisms, I will make it try to be as easy as possible when drawing everything. So right now I am drawing out our alcohol, and we see right over here that we have our OH, our carbon, and our three CH3 methyl groups, 1, 2, and 3. So we're going to go ahead and draw out our hydrogen halide. And you can see I'm drawing the electrons. I like to draw them around the oxygens and around the halide, because as you know, when we're going to be drawing electron arrows, we're going to want to draw them from the electrons to the element that it's going to be picked up. Now I want to change color, and I don't know where my color palette is. There we go. Okay, so I'm going to be drawing the electron arrows in blue, baby blue over here, so you guys can see what's happening, and that's going to guide us through the process. So the first step of any mechanism, you want to take your two reactants, the two things or more that you know are going to do the first steps. They're going to make everything start moving, and you're going to want to draw them out. And you might want to put it, expand it out a bit at first so you can see what's going on. Now, in most cases, the first step is going to be getting a proton or a hydrogen. Now, we're going to get that proton. We're going to see, which one would we want to take over here. Do we want to take this proton? Do we want to take one of these protons, or are we going to take this proton? We're going to want to know which one is going to be doing the moving. Now, in most cases, when you have OH, hydroxyl group, you're going to want to get rid of that group. You don't want to have that staying on, because you want to replace it with something else. Now, when you want to replace it with something else, can we just rip this off right here? No, because the bond between C and O, it's pretty strong. There's not a real easy way of moving it off. Now, something we learned in general chemistry is that plus signs and negative signs, when there's charges on compounds, it doesn't go very well. We don't want those plus signs and those negative signs. So if you do manage to get a plus sign or a negative sign, you're going to disrupt the molecule a bit, and it's going to start ripping itself apart, which is what we want to accomplish. So that's exactly what we are going to look into right over here. So we want to rip off this OH group, and it wants a hydrogen. Well, it's no point it going to get a hydrogen from itself. It's going to get one from over here. So we're going to draw an arrow leading from the electrons to the element that we want, which is going to be the hydrogen. Now make sure you start on the electrons. It could be tempting to draw it in the other direction. Pretend this is like a hand, and this hand is going out to rip out this H over here, and it's going to want to steal it. Now this chloride is going to be by itself, and needs to obviously get the electrons that are present in this bond, because this oxygen has its electrons, which it will be donating to its little buddy over here who's going to come over. So we'll draw a arrow from the bond, which contains the electrons, onto your halide. And then we're going to draw the other side of the reaction. And we're going to see that now this O over here, this oxygen, actually has a second hydrogen. And we're going to see how that affects the sign. And we call this step a protonation, obviously because we are moving a proton, and it's probably going to be one of the most common steps you're going to see in any mechanism. So you can get used to the process of stealing a proton onto an onto an oxygen, sorry. And then we go drawing everything out. Now, what do we notice about signs? This is a little trick which you can use to, if you're not too sure where you should be moving certain things or how many steps and how many arrows belong in each line. We can see that this oxygen over here has 1, 2, 3 bonds with other elements and 2 free electrons. And as we know by formal charges, that will give it a value of 5. And since oxygen likes to have 6 electrons, the 5 is actually 1 lower than 6, so it's going to be given a positive charge because that means it has 1 less electron, and electrons are negative, so you'll give it a positive charge. And over here on chloride, since we know that chloride belongs in the 7th column, it would like to have 7 electrons, and now it has 8, 1 more electron than it would like. Electrons are negative, so it has a bit more negative than it likes. Now, we want to balance the charges on each side at all time, the net charges. On this side, we see that we have 0 charge, right? 0 charge, plus 0 charge. We see there's no positives and no negatives on any of these elements. And over here we have +1 charge. And over here we have -1 charge. I'm going to scroll down a little bit so I can show you what I mean. These two, if you add them up, you get 0 on the reaction side. And these two, you add them up, you get 0 on the product side. And you always want to make sure that's true. If if you're not too sure how much stuff should be moving, use this little theory that the sides have to have the same charges at each step. Now, we're not close to finish because we see we haven't even completed our chloride is still over here. We want to bring this guy over here. Now what we're going to do is we're going to move down to the next step. A mechanism has a lot of steps to it normally, so we're going to want to string these steps together to see what happens in which exact order. So we're going to want to come back and redraw the little thing that we just formed right over here with our 2 hydrogens on the oxygen. And like we see, that has a positive sign. I'll put that positive right over there. Now, this guy doesn't like it. He doesn't like to have that positive sign on it, and it's going to start ripping itself apart. Now, this step only applies for secondary and tertiary ones because we're going to be forming a carbocation. A carbocation is going to be when you have a positive charge on a carbon, and we're going to see exactly how that forms. But first, this guy is going to rip itself apart. It doesn't like to be on its own like this. It wants to go away and be water. I mean, look at this. It looks exactly like water, and water likes to be water. So it doesn't want to be attached to this little guy over here. So what it's going to do, it's going to leave on its own. You're going to draw the arrow going from the bond to your oxygen. And that's going to go ahead and form. You can see right this. The carbon is going to lose its, the bond was giving it, it doesn't have 2 electrons here. It's actually going to have 1, 2, and 3. And we know carbon likes to have 4. And that's going to give it a positive charge. So we can see how the positive charge went from over here. We have a positive charge on the oxygen. And it's going to go all the way over here to the positive charge on your carbocation. I'm going to write that name right down for you guys. And then, of course, we're going to have water. And water, it's happy on its own and doesn't have a charge on it. And we can see that the charges add up from +1 over here to +1 over here. So the charges have been preserved. Now this step, it's going to be the slowest step, and that's why we're going to call it a rate determining step. So we're going to write slow. It's going to take its time because it's going to rip itself apart. It's just the bond here, the electrons are going to the oxygen, and it's just slowly ripping itself apart. Now we see, what do we have here? We have water, and we don't need to worry about the water right now. We really want to focus on this carbocation because now we have a positive charge open up over here, and we still have the negative charge from this chloride ion over here. And now what do we know about magnets? Opposites attract. Something we know, playing with magnets like a little kid. So we're going to do exactly that. CH3. So we'll draw out what we just formed, our carbocation. and I'll put our little plus right over here, and I'll draw what we had before, which will be our chloride ion, which is sitting around with 8 electrons. It's one more than it wants. We have a negative charge over here and a positive charge over here. And what do you think they're going to do? They're going to meet up and they're going to form what we wanted, our tertiary hydrogen. Oh, that's not that one. Sorry. Our tertiary alkyl halide right over there. So how are we going to draw it? We know that the electron arrows would like to go from the electrons to the element it's trying to grab. Where do we see a lot of electrons? We see them right over here on a chloride. So that arrow is going to go right to your carbon that has the positive charge. Make sure it's going to the one with the positive charge and not these little guys over here, because they are not interested. They don't have that magnet ability that we are looking for. And that's simply going to form our tertiary alkyl halide. We can draw our little electrons on there, and the fourth set is in the bond, and obviously H2O will come down from over there. It's our other part that we have left, which is our water. This is obviously H2O, just in case you guys are new to seeing the form for H2O, and it's just going to go down. You don't need to draw an arrow. You just need to assume that this is still in there, and we're looking at this guy in the next step. And that's exactly how we form our tertiary alkyl halide. And our little byproduct, which is water. But you're never going to do this to get water. You're going to do it to get the tertiary alkyl halide, and that's when we start off with an alcohol. So if ever you get a question that involves an alcohol and a hydrogen halide, you're really going to want to go to form the alkyl halide in the end by just simply reversing the OH with your Cl or whatever halide you get. If you have a secondary or a primary alcohol, you might have little differences in the mechanism. You'll mostly get them with the primary ones, and secondary can go either way. And I'm going to have a video coming up right after this one which will specifically deal with primary and some of the secondaries that behave a little bit differently, because we will not have this step over here because this positive charge is getting stabilized by all of these guys around it. Now, if you don't have all these guys around it, you don't have anybody who's helping you stabilize your compound, and it makes stuff go a little bit weird. So I'll save that for the next video. It is a complicated step in organic chemistry. It's where it starts to get really hard. So if you have any questions or comments, please feel free to post them below or contact me on Twitter. I will respond to you as soon as I possibly can. So once again, thanks for watching, and have yourselves an awesome day.